Hello, all. Welcome to part two of your stoichiometry notes. This particular type of stoichiometry is called limiting reactant stoichiometry. And basically, to explain limiting reactant in a very simple term, it's whenever you run out of one of your reactants, that's it. You're done. The reaction cannot continue. So think of it like you're having a bonfire. It's about springtime. Hopefully, you can get outside a little bit, um, and you want to make s'mores, but you only have half a bag of marshmallows. When those marshmallows are gone, the reaction's done. The s'more making's over. So very similar to what we're seeing here. In a chemical reaction, once one of the reactants is used up, the reaction will stop. We call this specific reactant that gets used up the limited reactant. The other reactant will have some quantity that's unused. We call that excess. And so we're always going to start with the balanced chemical equation. When solving for a limiting reactant, we need to find out which one that is. The excess will be unused. And then we're going to go through that dimensional analysis, that same double roadmap that we did before, and then we can solve for what's called the percent yield of a product as well. So basically, in order to explain that, what you have in the lab isn't always what you get in the real world. And we've done a little bit of that so far. So ask yourself, did you balance an equation? I'm going to show you a couple different methods to solve for this. You can do kind of like a haves versus needs chart, and that'll be specific to your teacher if they want you to do that, or if they want you to go about it a different way. But just like with regular stoichiometry, there's so many different ways you can do these limiting reactant problems. So think about another couple things. When you choose one of the two reactants to start with, you may, by default, choose the given reactant that ultimately gives you the excess, which means the other is the limiting reactant. This also means that you can determine how much excess reactant remains. And again, that's something that we'll use our chart for that is going to end up being beneficial to you. So let's go ahead and I'm going to show you the two different ways with our sample problem here. And I don't think one way is better than the other. It's going to be specific with what your teacher wants. And that way, just ask them that question and they can answer that for you. Step one, of course, a balanced chemical equation. So we've got one carbon on the left, one on the right, one oxygen on the left, one on the right. Not a whole lot we can do there. You'll notice we've got the 3 hydrogen as the CH3, but then there's another one, so that makes a total of 4. So our 2 out in front will satisfy that. So the question reads, if you react a 152.5 grams of CO and 24.50 grams of H2, how much CH3OH would theoretically be produced? So notice we're given 2 initial reactant mass, and that's just kind of how we need to make our way into this particular problem. So we're going to go ahead and start calculating out our stoichiometry work. We're going to need to do both reactants. So I'm going to go ahead and write the mass of both reactants. And we're going to do dimensional analysis with both of them. And we're going to convert one reactant to the other. So it doesn't matter. I guess you don't technically need to do this bottom part. So let's go ahead and not do this bottom part here. We're going to convert the carbon monoxide, the CO, over to H2. So what that's saying is I have 152.5 grams of CO. I want to figure out how many grams of H2 do I need in order to fully react that 152.5. So to do that, we need to use that balanced chemical equation. Following my dimensional analysis, we'll have the molar mass of CO. Mole ratio is 1 mole of CO to 2 moles of H2. Go ahead and pause this to enter this information into your calculator. And what we would find is that would come out to 22.00 grams of H2 after you've entered that into your calculator. So in order to fully react, I need 22.00 grams of H2. I was given 24.50. So we know then, since I need 22.00 and I was given 24, that this is our excess reactant. Okay, our excess reactant. I have that amount left over. I'm going to have extra. For the CO, then, this would be my limiting reactant as it was completely used up. So that's one way to identify your limiting and your excess reactant. To figure out then how much would theoretically be produced, we always do the math with our limiting reactant. Once we find out the excess, we very rarely use that number. So we're going to set up another stoichiometry problem in order to figure out and convert our limiting reactant to the product that we're searching for, the CH3OH. And we're looking for, it does say how much would theoretically be produced. It doesn't specify mass, but we're going to go ahead and solve it as if it did. 32.05 grams is the molar mass of CH3OH. Units fully cancel. Please pause the video to enter this into your calculator. But to correct number of significant figures, 1.745 times 10 to the second grams of CH3OH would be your final answer. And again, hopefully it makes sense to you why we use that limiting reactant to solve for that final answer. So that's how you would use the have versus need chart. I'm going to go ahead and show you a different way to do it. This way isn't better, it's not worse, it's just another way to approach it. And it's going to look like this. So our same balanced equation, we have our same variables. I'm not changing anything in terms of the problem. And this would be then the unknown that we're looking for. We're not going to use the have versus need chart for this one. Instead, in order to figure out which one's my limiting and which one's my excess, I'm going to convert both reactants to this CH3OH. And again, what that's going to tell me is which one creates a lesser amount, and that would be my limiting. So 152.2 grams of CO. 28.01 grams of CO. My units cancel. Do my mole ratio. 1 mole of CO for every 1 mole of CH3OH. Now I just need to get into something that I can compare the two with. So I'm going to stop at moles. 24.50 grams, and I'll explain that a little bit more here in just a moment. I'm just following that double roadmap or your chart, your reference document, whichever you prefer. So before, I could not compare the two numbers. They were different. I had grams of CO and grams of H2, so they aren't the same. But now, as I enter these into my calculator, I am going to end up with a mole value, specifically 5 point. And you're going to want to keep, I always tell my kids that you want to try to keep 6 significant digits here, just so that you can have a good comparison. And so we'll do hydrogen gas as well. Divided by 2, 6.064356. So now if we compare these two values, you'll notice that with 152.2 grams of CO, you can make 5.43377 moles, but with 24.50 grams of H2, you would theoretically be able to produce 6.064356 moles. The grams that you can produce with the H2 is more, so this is labeled as the excess, and this is labeled as the limiting. Then we would just carry on with the math from the limiting reactant, and we would convert that mole value using our double roadmap to grams. And then our mass was 32.05 grams. And after we take that value, and you want to try to do as little rounding as possible. So I go back and re-enter the whole thing, plugging that onto the end. And I end up with the same 1.74 times, I get 742 here times 10 to the second power. I'm going to go ahead and enter that in one more time just to be sure. 52.2 times 32.05 divided by 28.01. And that would be our final answer here. So slight difference in the decimal. It's just all going to depend on where you round that final answer. I'm not sure actually where I'm getting that slight decimal difference, but the setup is good. Okay, so if you have any questions on that, please reach out to your teacher. Again, it's up to kind of you to figure out exactly what way your teacher wants you to complete that work. Now, we can answer a few more questions with this, and I'm going to move through these pretty quickly because they kind of make sense. How much of an excess reactant is left over then? So if we go back to kind of the beginning, we were told that we have 24.50 grams. If we subtract that 22.00 grams, we end up with 2.50 grams of H2 remaining. So that's something that you can kind of keep in mind. We can go around and solve for different variables. And of course, there are ways that we can move these numbers around and get to that number as well. So again, with stoichiometry, specifically limiting reactant and all kinds of different types, you can go about it in a different way. For percent yield, if you think back to some of the labs we've done, the actual divided by the theoretical times 100 is going to get you that percentage value. The theoretical is what we calculate on paper. So for us, that's the value that we calculated, the 174.5 grams of the CH3OH. So if it's going to ask you what the percent yield is, it's going to have to give you, unless you were in the lab setting, a mass that was taken at the end of the experiment. Times 100, and we end up with 97.42% yield for that. So again, we're just looking at actual over theoretical, or how effective was our experiment. 97.42% effective. That's pretty good outcome. So Just in general here, it's kind of like a little word problem that we can use to kind of test our understanding. A chemical reaction has two reactants A and B. The reaction stops once B is all used up. Because B is completely used and the reaction stops, it's our limiting reactant, and A is left over. Okay, because B is fully used and A is remaining. It's just a quick definition there for limiting reactant. On this last page, last slide here, you do have your student example. I would say that before you move into doing any of the assessments, you get this student example correct. The answers are posted in that student version. Be careful, because with this here, we're starting out in volume. And so when you start in volume, you need to use density to convert to grams. So that's just a reminder. So let me know if you have any questions. Reach out to your specific teacher with any questions.